So we will first finish chapter 3 today. So let us go back to, we have stopped with the viscosity definition. Okay, we have seen that the viscosity can relate the shear stress to the shear rate. And we said that the viscosity behavior will change depending on the material. So first, for any material in general, with increase of temperature, the viscosity will decrease. Okay, because for example, if you heat a solid to the liquid state, at the solid state, the viscosity is nearly infinity, and as you heat to a liquid, it will become less and less viscous. Another variation of viscosity is observed with shear rate. In case the viscosity is constant with variation of shear rate, then we say that we have a Newtonian fluid. So the shear viscosity is constant for a certain temperature, while for non-Newtonian fluid, it's not the case. Okay. Now we will see together a graph showing different possibility of behavior of a fluid. The first one is the Newtonian fluid. For a Newtonian fluid, the variation of viscosity with shear rate is no variation. This means that the viscosity will maintain the same value for different shear rates. And therefore, the viscosity here is the slope of this curve, and it's a constant since I have linear variation between the shear stress and the shear rate. Now, other types of behavior are first the ideal Bingham plastic. For an ideal Bingham plastic, this behavior will not be purely solid and not be purely fluid. So if I consider stresses below a certain yield stress, so if I consider, for example, in this figure, stresses below 72 Pascal, I will have no shear rate, so no deformation. This means that my material is acting as a solid for small stresses below the yield stress. On the other hand, once we exceed this value of yield, which is defined as a yield stress, then my material will start to undergo deformation. So it will act as a fluid. So we say in this case that this behavior will depend on the value of the stress to behave as a solid or fluid. Who can give me examples of ideal Bingham plastic?
Toothpaste.
Exactly, toothpaste. Okay, because if you, in general, toothpaste is in a solid state, and when you squeeze the tube, okay, it will act as a fluid. Another example is mayonnaise. Okay, because if you, for example, mayonnaise can sit in a pile on a slice of bread if the shear stress is less than the yield stress. On the other hand, if you bring a knife and you put it on it, you will create a high shear stress on it, and in this case, it will flow smoothly in a thin layer. So when we exceed the yield stress, it will act as a fluid, and below the yield stress, it will act as a solid. Another behavior of material is the shear thickening fluids. So here you can see this curve is for shear thickening fluid. And in this case, as you can see, the viscosity, which represents the slope of shear stress with shear rate, will decrease with shear rate. Okay, so as you can see here, the slope is decreasing with higher shear rate. So from here, we say that for shear thickening fluids, the viscosity decreases with decreasing shear rate. With increasing shear rate, and in this case, the viscosity is not constant. Okay, who can give me an example of shear thinning fluids?
Quicksand ولا مخص?
No. Look, the idea. Yes. Why quicksand? What will happen?
Because if you move fast enough بقلبها, you will drown even further or faster.
Okay, so here the idea is that the viscosity will be reduced with increasing rate. Okay, and yes, in the case of a mixture of sand and water, when you mix them together, first it is if you want انت الاكزامبل اللي اعطيتني اياه هو العكس. Okay, because look, when you if you have a sand and water mixture at the beginning, it's easy to operate, it's easy to mix لانه بتكون viscosity relatively low. Okay, and when you continue to mix more بيصير المixture more viscous. Okay, so